Hi, this is another video from me. This one is find the equations of the tangent and the normal for f of x is equal to 4e to the x minus 3 cos x at x is equal to 0. So, first of all, write down the function f of x is 4e to the x minus 3 cos x. And then what we're going to do, in order to find the gradient of this function, we need to differentiate it. So f dash of x, a good notation, 4e to the x is itself differentiated. Now minus cos is plus sine. Okay, if you think about it, it goes, if you differentiate sine, you get cos. If you differentiate cos, you get minus sine. If you differentiate minus sine, you get minus cos. And then when you differentiate minus cos, you get back to sine. So this is going to be plus 3 sine x. So then we need to put x as 0 into that. So x is equal to 0. F dash is 0. So careful use of notation, please. Is 4 times e to the 0 plus 3 sine 0. E to the 0 is 1, so we're going to have 4 times 1. And sine of 0 is 0, so we're going to have 3 times 1. So we've got a gradient of 4 when x is equal to 0. For the y coordinate, for this we need to use f of x, so we need to find f of 0. That's going to be 4e to the 0 minus 3 cos to the 0. So that's going to be 4 times 1, and cos of 0 is 1 as well, so minus 3 times 1. So we're going to have 4 take away 3, which is 1. Right, in order to find, so we've now got all the information. In order to find the equation of the tangent, we're going to use y minus y1 is equal to mt x minus x1. So, good idea to label what each thing is. So this is x1, this is going to be y1, so good idea to label it like I'm doing, and this is mt. Then substitute into the formula. So we've got y minus y1, so y minus 1 is equal to mt, which is 4, times x minus 0. So we're going to have y minus 1 is equal to 4x, and then normally we'll take the y over here, so we've got 4x minus y plus 1, and maybe we'd write it like this, 4x minus y plus 1 is equal to 0. Now, if we got the gradient of the tangent, then the gradient of the normal is perpendicular for that. The product of the two gradients has to be equal to minus 1, which means that the gradient of the normal is minus 1 over the gradient of the tangent. So applying that, we're going to have that mn is minus 1 over the gradient of the tangent, which is 4, so it's going to be minus 1/4. And then we can just use the same formula again. So the equation of the normal is going to be y minus y1 is equal to mn x minus x1. So substituting in again, just going to label this mn so we remember. So it's going to be y minus y1, which we will label to be 1, is equal to mn, so it's minus 1 over 4. Please write your fraction one above the other. Don't forget the minus sign. X minus 0. Right, now because we've got a fraction here, it's best now to take the 4 and take it up to this side. So we're going to have 4 brackets y minus 1, and then we've still got minus 1 times x, that's minus x. Expanding the bracket, we get 4y minus 4 is equal to minus x. Taking the x over to the other side, we've got x plus 4y minus 4 is equal to 0. Now I thought it'd be quite good to look at this with a diagram, so good old GeoGebra. So hopping over to GeoGebra, so here we have our function, f of x is 4e to the x 3 cos x, and here we have it. If I click, I can bring up the point P. Okay, there's the point P. Okay, and if you're going to do this, you need to have equal aspect axes. And there you can see the gradient of the tangent, y is equal to 4x plus 1. And here you can see the gradient of the normal. I'll just move that slightly up there. So you're going to get the normal as minus x minus 4y is equal to minus 4. So it's x plus 4y is equal to minus 4, which is what we got. So you can see there. Okay, hopping back again. Alright, quite good fun. If you move it around, you can see like the tangent and the gradient and the normal moving. Remember, the tangent and the normal are like perpendicular to each other. So this GeoGebra app you can find in the notes of this YouTube video. You can find the link to it on on to GeoGebra Tube, so you can have a go for yourself. Okay, thank you very much for watching, and I hope you got something out of this.